Hello everyone, welcome to our channel. So here we are going to take one more question asked in the GATE exam. So this question is related to fundamentals of control system. This question they asking about the like they given the transfer function and they asking which type of nature, you know, nature of system, how system would behave, whether it is a overdamped system, okay, whether it is a overdamped system or critical damped system and underdamped system, and one more is a undamped system. This is also like oscillatory in nature, okay, but here they are talking about overdamped system, critical damped system, underdamped system. For to solve this kind of question, like the standard second order system they given, and as we know standard second order system TS for unity feedback system, k omega n square, k omega n square by a square plus 2 zeta omega ns plus omega n square. Alright, where k is DC gain. Okay, how to find out DC gain? Just put the s is equal to 0 and find out. Okay, so alright, so here where let me explain this zeta is a damping ratio, okay, and omega n is a natural frequency. In radian per second. All right, and okay, and one more term you can also remember, zeta omega n is a damping factor. Okay, anyway, so this is a we need to know the details to solve this question, and how would know like underdamped, critical, and overdamped system. For this, like damping ratio is very important here. If damping is 0, means there is no damping at all, then system would oscillate. System would oscillate in nature. System is unstable. Alright. System is unstable system. Alright. Just undamped. Not undamped system. Okay. And then if zeta greater than 0, less than 1, then it's called the underdamped system. Alright. And if zeta is equal to 1, then it's called the critical damped. And zeta greater than 1, that's called the overdamped system. Okay, so this way we can find out the weather system is underdamped, critical, overdamped. Okay, so for this given question, let me solve it. So P in option P, they given one transfer function 15 by s square plus 15s plus 15. Okay, if you find out the DC gain is 0 because sorry 1. If you put s equal to 0, then it's coming 15 by 15. It will be k is equal to 1. All right. So here DC gain 1. So if you compare omega n square is equal to 15. All right, and 2 zeta omega n equal to 5. Okay, we find out the zeta value, then only we can find out the, we can tell about whether how system would behave. Okay, so 2 into omega n under root 15. All right, Here we'll take only positive value. Like if you have doubt about this, like omega n is equal to plus minus under root 15, you will take only positive, then only system would be stable. All right, because zeta should be positive. Okay, should not negative. So here 5 by 2 into root 15. So here what's the value we get actually? Let me solve it. So 5 divided by 2 into root 15. All right. So it's coming 0.645. Okay. All right. 0.645. So you know zeta is less than 1, greater than 0. So this this transfer function represents the system would behave the underdamped system. Okay. So either in option either C or D out of the one option would correct. Okay. And we go for second option 25 by s square plus 10s plus 25. So here omega n square is equal to 25. So omega n is equal to 5 and 2 zeta omega n is equal to 10. Then 2 zeta omega n is 5 and then finally zeta is coming out. It turns out 1. So you know what is it? Zeta is 1. This is a condition for critical damped. Alright. So for this option is correct. Second option. Alright. So remaining is a final is a overdamped system. For the zeta is greater than 1. So in our exam, no need to solve further. But for sake of completeness, just I am calculating. So here for this are this transfer function. Here omega n square is equal to 35 and 2 zeta omega n equal to 18. Alright. So zeta is equal to 9 by under root 35. Okay. So let me solve it. So this is 9 divided by divided by the 35. It's coming out 1.52. Alright. So here 1.52. Okay. So here zeta is greater than 1. So finally this is overdamped system. So this question was very simple. So we get the answer will be I think C option is correct, right? C option is correct. And in case of this underdamped system, let me find out roots of the type of roots. Okay. So like roots I am talking about roots means poles. Okay. And denominator polynomial roots is nothing but the poles of the system. So in case of under system, pole will be, you know, in a stable system, pole always lie in the left hand plane of the S plane, right? This is my j omega axis. This is my sigma means yes, real part. Okay, this is S plane. So in case of stable system, in case of stable system, all poles should be lie in the left S plane. In case of marginally stable, like it should not be, you know, repetitive poles should not be there in the on j omega axis. Okay, we will discuss about this also. But here you can see like under dam system poles would be in a conjugate nature, but is in negative side. Okay, two poles will be there. Okay, like here you can, if you solve it, they given x square plus 5x plus 15. Okay, so just we are solving it. Roots poles P1 and pole P2. So just I am applying the Sidracha rule. So minus b minus 5 plus minus under root b square 5 square minus 4 into a 1 into 15. Okay, by 2 into 1. So 25 minus 60 by 2. So it coming out 60 minus 25. So it's coming out 5.91. Okay, over value 5.9. This is a root 35 minus root 35. So for this under root minus 1, this is imaginary part j. Okay, by 2. So as we know, this is our roots here. Okay, so what is the final value? Plus minus 2.5. This is a 2. Just I am dividing 2 value. Okay, by 2. So 2. All right. So nearly. So this is the roots will be there for this undead system. So in case of undead system, poles would be in conjugate, complex conjugate. Okay. And in case of critical damped, poles should be equal and real. Let me calculate here. You can see for a given system. Here s square plus 10s plus 25. Okay. S square plus 10s plus 25. 10s plus 25. So here you can see if you apply the Sidracha rule. What is the Sidracha rule? Let me, this is quadratic equation ax square plus bx plus c, where a is not equal to 0. Then only this quadratic equation will be exist actually. So for this, what is the roots for this equation? So x1 and x2 minus b plus minus under root b square minus 4ac by 2a. Okay, so the same thing I am applying here. So here a square plus 10s plus 25. So minus b 10 plus minus under root b square 4 into 25 by 2 into 1. Alright, this is my pole P1 and P2. Alright, then so here minus 10 plus minus this is 100, 25, 100 by 2. So finally it will be plus minus 0 by 2. So minus 10 by 5, sorry 2 minus 5. This will be equal actually. Alright, minus 5 minus 5. Okay, then here you can see if you in S plane what's the roots actually minus 5. In case of S plane presentation of the S, we can present pole as the cross mark and 0 present the circle like. Okay, so here is a real means it will be conjugate, it will be coincide each other means multiple pole will be lie. Okay, so here for we can say critical damped, so pole will be lie in a real. Okay, after this in case of overdamped system, you can see in case of overdamped system, so overdamped system like this are A35 a square plus 18s plus 35. So in this case, a square plus 18s plus 35. Okay. So in case of overdamped system, poles will be real and distinct. Okay. So, but in case of critical, poles will be real and equals each other. Okay. So let me solve this also for and like proving whether how poles coming. So minus, just I'm applying the Sridhar rule. So pole P1 and 2. B square 18 square plus 4 into A1 35 by 2. Alright. So let me solve it. So 18 square 3324, right, minus 4 into 35, so it's coming out plus 184 by 2. So 184, it coming out root 13.56 approximate by 2. So if you solve it, 9 plus minus 6.718. So what is your final poles? P1 just take a one at one time plus, so 9 plus 6.78 is coming out, and one take second time is, sorry, this is a minus, right, because all poles would be in a left and S plane. So we just subtract it, so it will be 2 9 2, so here 8 2. All right, so here is a, so this is one pole minus, and second pole is, if you take minus minus, take here negative sign. Okay, so it will be minus 15.78. So pole will be lie in a one pole here, minus, okay. Then you can see pole is real and distinct. So like that we can discuss more about this, in case of root locus based on the variation of k means DC gain, and we can see variation of pole. This called the root locus, how poles, how system would behave, how system poles would vary. Okay, so we will discuss more about this. So I think that's all for this video. We will not deep more about this. Okay, so we have understood like our underground system, our poles would be in nature is complex conjugate, and critical damped poles will be real and equals, and overdamped pole will be real and distinct. All right, and one more actually here is not given. This is like a undamped system. This pole will be imaginary conjugate. Okay, so this will be lie in the j omega axis. Okay, So like that we will discuss more about this, but I think that's all for this video. Please, if you like this content, please subscribe our channel, and please support to us. So that's all for this video. God bless you all.